Hey everybody, my name is Wyatt Covey, and today I will be presenting for my Engineering 2070 class, Materials and Processes. I will be giving a presentation on the material and design of non-pneumatic tires. So as most everybody knows, first vehicle had the wooden wheel. This has evolved now to what we know as the rubber tire, or what's on everybody else's vehicles today. This is also called the pneumatic tire, which means it just has air in it. The rubber was added to these tires to increase the traction. This helps the driver have more control over the vehicle when driving it, creating a smoother ride. These pneumatic tires are now being tried to change to non-pneumatic tires, meaning that they would have no air in them. So the problem with pneumatic tires is that the pneumatic tires create a lot of pollution when they're being degraded, but the airless or non-pneumatic tires have spokes that are made out of a specific resin, which would be fully recyclable. The non-pneumatic tires are also cheaper, and they would require less maintenance because since there's no air, you wouldn't need to worry about having flat repairs or the tires blowing out and having to replace them from that way. And so this is a figure of the non-pneumatic tire and the parts that go into making it. So this outer ring is the tread. This would be the same as what the pneumatic tire has, in which it would add traction to the road and it would help the driver control the vehicle better. So this wouldn't change, but then there's the deformable wheel, which is in the center, and this is what would bolt up the tire to the vehicle. And then there's the shear band between the spokes and the tread. And then the spokes, which is what is replacing the air out of pneumatic tires. This is what holds the vehicle up. So this is what the main testing is going into now, is trying to find the best design structure and the best material to use. And so there was a study done on SolidWorks where these 3 different design structures were made. And the study was trying to find out which design structure and which material would be best. And so once the structures and the material were made, they were tested for the stiffness and the deformation of each structure. And so on the left is the honeycomb design, the middle is the diamond design, and then on the far right is the triangle design. And so each design was made out of the 3 materials, and they were all 3 tested based on what structure it had. And so the first material that was used was a acrylonitrile butadiene styrene plus polycarbonate, or ABS plus PC. The second material was a high impact polyestyrene, or HIPS. And the third material was a polyethylene terephthalate, or PET. So this table shows the deformation in millimeters that was produced from the previous slide. And so it shows that overall the diamond design structure had the smallest amount of deformation, and then the honeycomb design had the highest amount of deformation for the overall amount of materials used. And then the triangle HIPS had the highest overall, so that would be the worst design to use with that material because it had the highest amount of deformation. But the best material and best design structure to use would be the diamond PET based on this test because it had the lowest amount of deformation. And so there was another study done to find the vertical stiffness of the tire using the Ectron PL 2003, which is in the top left of this slide. And so this tire, it would be spinning on the machine, and then a force would be pushed to the bottom of it, which would show the amount of displacement. And so on the right side is the graph that was produced from the test with the vertical load on the x-axis, and then the displacement in millimeters on the y-axis. And so it showed, this would make sense because as the vertical load is going up, the displacement is also going up. And then for each point of the graph, there's a max and min value of the amount of displacement, showing that the test was done for each load multiple times. So the socioeconomics part about the airless tire is that they're environmentally friendly. As said earlier in the slides, these tires are more environmentally friendly than the normal tire because they are made of materials that can be recycled, and the pneumatic tires create a lot of pollution. So the airless tires have the resin in the spokes that can be recycled, but the pneumatic tires, when they are discarded, they increase pollution levels. The landfills are more full, and it also increases CO2 emissions. So if the pneumatic tires were replaced with the airless tires, this would increase the pollution levels, the landfills would be less full, and also the CO2 emissions would not be as high. So what's being done now? There's many tire companies that are working on creating airless tires, but one of the biggest companies that I saw was Michelin was working with GM or General Motors, and they said they had a goal of 2024 to start putting these airless tires on vehicles. They've created the Michelin Uptis prototype, and they also call it the Unique Puncture-Proof Tire System. And these tires are being tested, and the companies say that they are trying to produce the most safe and sustainable tire on the market. And so these two pictures on this slide is a prototype of the Uptis tire for Michelin. And this is what they're testing now, trying to figure out what the best spoke design and best material would be to use, and testing each tire with. So there's a lot more positives than negatives for the airless tire. The positives would be they are cheaper, they last longer, they're safer because they won't blow out on the road because they don't have air in them. They also would not need flat repairs, and they're more environmentally friendly because they produce less pollution than the pneumatic tire. The negatives is that since they're new, they haven't been studied very long, so there's not a lot of information about them, and they're still being tested on which design, structure, and material would be the best to use. The other weakness is that the spokes of the wheel can deform, which would cause the driving in the vehicle to have vibrations, which would produce a very rough ride for the driver. So overall, the airless tires are new to the tire industry and only being used on small machines like golf carts or lawnmowers. And on these pictures, it's a lawnmower, and the rear tire is the airless tire. And then on the bottom picture, you can see how the airless tire forms itself to the curb to help it get up and hold the weight of the vehicle. They're still being tested to decide what materials are best to be used and what the best design is for the spokes of the wheel. However, the airless tires are much better than the pneumatic tires because of the environment, the environmental reasons, the price, and performance. But based on the study that was done earlier in the slides, it showed the best design of the spoke structure should be the diamond design made of the polyethylene terephthalate. This would produce the smallest amount of deformation, so that's what should be used to produce the airless tire.